Hello student, today I am going to discuss about how magnetic dipole moment produced due to when an electron is moving around the nucleus. Especially we are considering hydrogen atom. In hydrogen atom we know in the nucleus one positive proton is there and electron is revolving around that nucleus. Okay, so here you see in figure 1, okay, the nucleus is present at O point, at the center of this circular path, and electron is revolving around this circular path with whose mass is me and velocity is v. At a distance, radius of this circular path is we have considered smaller. Okay. Now, as electron is revolving and when it's complete its path, what happened? It produces a current loop. Okay, it means we know as electron is revolving here, we have considered electron is revolving in anti-clockwise direction. So current is flowing in clockwise direction, opposite to the flow of electron. So as current is flowing through this loop, so magnetic moment, it means it produces a current loop, so there is a magnetic moment produced. Okay, now we have to derive this expression. What is this? Here mu e is the magnetic dipole moment of the electron, E is the charge of electron, 2 ma is the mass of the electron, and L is angular momentum. Okay, so magnetic dipole moment of the electron is denoted by mu e. Sometimes it is also denoted by capital M also. Now we will derive this expression. We want to derive this expression. Now, as the electron is revolving around this circular path, okay, mass of the electron we have considered me and radius of this circular path we have considered smaller. Now angular momentum, here it is denoted by capital L letter, so equal to me Vr. We know this. Here V is the linear velocity of the electron. Okay, this is equation number 1. Now if t is the time period, it means to complete one rotation, time required to complete one rotation for this electron, if we know it is called time period, and if it is denoted by capital T letter, then T. Now current I equal to charge by time, so I equal to E by T. Charge possessed by electron is E, small e, so I equal to E by T. Okay, now time period T equal to 2 pi r by V. 2 pi r is the total circumference of this circle and V is the velocity, linear velocity, so time period T equal to 2 pi r by V. Okay, now putting this value of T here in this equation, what we have, I equal to this EV by 2 pi r. Okay, now we know that to find the magnetic dipole moment we have to use this relation, m equal to IA. Okay, now area of this loop, if it is denoted by capital A letter, then capital A equal to pi r square. Okay, now magnetic dipole moment, it is denoted by mu e or capital M according to formula IA. Now putting the value of I EV by 2 pi r and A pi r square, so A mu e equal to this one. So after solving this we will get mu e equal to EVR by 2. Now VR equal to this one from equation 1. Okay, now putting the value of VR in this equation we will get this thing. Mu e equal to E by 2 me into capital E. This is equation number 2. Okay, now in vector notation, because we know magnetic dipole moment is a vector quantity, and L is angular momentum is also vector quantity. Okay, so we can write mu e, vector mu e equal to minus of E by 2 me in first bracket vector L. So this is equation number 3. Now why you have taken minus sign? Because direction of mu e and direction of vector L is opposite to each other. Now see in this figure number 1, as electrons is revolving in anti-clockwise direction in this circular path, so angular momentum, direction of the angular momentum is away from this board, means along this direction, okay, perpendicular. Now, and what is the direction of magnetic dipole moment in this case? Now, as electron is revolving anti-clockwise, so current is flowing in clockwise direction. Okay, it means when we know when a current is flowing in a circular path in clockwise direction, then this phase act as a south pole and opposite phase act as a north pole. Now, direction of the magnetic dipole moment is from south to north. So here in this figure, the direction of magnetic dipole moment is into the board, okay, perpendicular to the board, and direction of the angular momentum is away from this board, so they are opposite to each other. So that's why we have taken minus sign. And this is the relation between, in vector relation between magnetic dipole moment and angular momentum. This equation number 3. Okay. Now from equation 2, we can write mu e by L equal to E by 2me. Okay. This ratio of magnetic dipole moment to the angular momentum is called gyromagnetic ratio. This is called gyromagnetic ratio, this ratio, which is equal to E by 2me. Okay. Now we want to find this expression. So now from Bohr's theory, it is not known to you till now. Okay, we will discuss these things in atomic physics. Okay, now according to Bohr theory, Bohr gave 3 postulates. Okay, out of that 3 postulates, these postulates is very important. According to that postulate, angular momentum is equal to nh by 2 pi. Here n is the integer 1, 2, 3 number, h is Planck constant, and 2 pi is just one value. So here n is angular momentum, n equal to 1, 2, 3. Here n is also called principal quantum number. Okay. Now and h is called Planck constant. Its value is 6.62 into 10 to the minus 34 joules second. Okay, this is the unit. Okay. Now putting this value L equal to nh by 2 pi in equation number 2, in this equation in place of L, what we have, mu e equal to E by 2 me nh by 2 pi. So mu e equal to this one, n into eh by 4 pi me. Okay, here n is principal quantum number. If n equal to 1, then we have to put 1. So then in that case mu e equal to eh by 4 pi me when n equal to 1. Okay, so in this case, this magnetic dipole moment is called Bohr's magneton. Okay, because this is the magnetic dipole moment of the electron when it is revolving around in first orbit. So magnetic dipole moment of the first orbit of the electron is called Bohr's magneton, and this is the expression mu e equal to eh by 4 pi me. Okay, this is called Bohr magneton. Okay, so in this way we can find this expression. Okay, so you just go through this, and this will be the last problem, last topic related to magnetic dipole moment. Okay.